Good morning, this is Dr. Turner for Integrated Math 2. Today we're getting into 10.3, which is looking at combinations. Again, if you haven't watched 10.2 already, we covered permutations. Permutations and combinations are usually taught at the same time. The difference is that in permutations, we care about the order in which we are arranging a set of objects, whereas a combination, we're just looking at a group of objects and we don't care what the order is. So we'll go ahead and get started here. Going back to permutations, we had an example in the 10.2 video of saying, okay, let's say I took some blocks, say A, B, C, and the question was, well, how many ways could we arrange those? If we put them in a certain order, how many ways could we arrange those? Now, we used all of our blocks in that example. We said, okay, between A, B, and C, there's 6 ways that I could organize it. For just our combination video here, let's look at, let's say I had 4 blocks. And so out of these 4 blocks, based on our permutations that we did, if I wanted to organize the blocks 4 factorial, that would give me 24 ways that I could organize the letters A, B, C, and D. That's permutation, where A, B, C, and D is different than D, C, B, and A, because we care about the order. Combinations don't care about the order. So, as an example, let's say I wanted to, out of 4 blocks, A through D, I want to choose 2. Question is, how many groups of letters could I choose? Now, if I cared about the order, that would be 4 permute 2. And 4 permute 2, or 4 permutation of 2, is looking at there are 24 ways to organize these blocks, but I only care about 2 of them. So 4 minus 2 gives me 2 factorial, which gives me 12. So there are 12 ways to choose 2 blocks and organize them. And this is a small enough group that we can kind of work it out. So I could have AB, I could have AC, I could have AD, or I could have AC, or I could have BA, or BC, or BD, or I could have CA, CB, CD, or I could have DA, DB, and DC. Now, those are the 12 combinations of 2 blocks if I was caring about order. With combinations, we don't care. Basically, we're saying that AB is the same group of letters as BA. So if we don't care about order, we're going to count that as 1. And we can go through here and find similar matches. AC is going to be the same as CA. AD is the same as DA. BC is the same as CB. BD is the same as DB. And last but not least, CD is the same as DC. So in that regard, rather than having a number of 12, then we have a number of 6. So there are 6 combinations here of 2 blocks. Okay. Now that works with a smaller set of numbers, right? We had 4 blocks. How many groups of 2 can I pick? Just like with permutations, though, if I had the entire alphabet, I wouldn't want to have to write out all of these sets. It'd be too cumbersome. So, just like with permutations, there is a combination formula. And your combination formula is going to be NCR. Again, depending on your calculator, it might be written as C with and then N comma R in parentheses, but it's representing the same thing. And it's going to look kind of similar to your permutation formula. It's going to be n factorial over n minus r factorial, but you're also going to divide by r factorial. And so I always ask this question when we're in person, but the question is, okay, well, what does this represent? Right? This is basically the same formula, but I also have an r factorial in the denominator. What does that represent? Well, that r factorial is taking care of what we did up here, right? It is eliminating the duplicates. If A and B and B and A are the same group, then the r factorial is is taking care of that. Basically, how many ways can I organize, in this case, 2 letters? 1, 2. It'd be similar if we had like 3 letters, right? If I chose A, B, and C, then it would be 3 factorial, or there would be 6 ways I could organize that same group. So long story short, that's what that is taking care of. For you guys, you're going to have a couple questions that will involve this formula. You might have a word problem, or you might just have an NCR problem. So, for instance, 6C3 is asking if I have a total of 6 things, how many ways can I choose 3 of them? Right, so using the formula, this would be 6 factorial over 6 minus 3 factorial times 3 factorial. Now again, if you're using a calculator anyways, it sort of eliminates some of the algebra of this, but the goal is that you're able to do this without a calculator. So if I'm looking at 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1. And then 6 minus 3 would give me 3 factorial, so I have 3 times 2 times 1 times 3 factorial, 3 times 2 times 1. So without a calculator, I can, of course, just like with permutations, cancel out any pairs of numbers that I have. And then I would cross simplify. 4 divided by 2 is 2. 6 divided by 3 is 2. So 2 times 5 is 10 times 2 gives me a final answer of 20. There are 20 groups of 3 that I can pull out of a group of 6. And that's how you would do these problems. Again, it could be something like a combination problem, or it could be a word problem. Now, there are some special cases where you get something kind of like a simplified answer. So for instance, like 10 choose 1 or any n choose 1. When I go to do this, I end up with 10 factorial over 10 minus 1 factorial times 1 factorial. So if I were to write this out, and you can do this, 10 times 9 times 8 times 7 all the way down to 1, divided by 10 minus 1, 9 factorial, 9 times 8 times 7, all the way down to 1, you're going to end up canceling out everything except the 10. So you make a note of this here, and this would be a special case, but if you have n choose 1, that is going to be equal to whatever your n value is. Now the same works if you have 1 less than your n. So let's say I had 10 choose 9. Well, in that case, I would have 10 factorial over 10 minus 9, which is 1 factorial, times 9 factorial, and again, I would have 9, 8, 7, 6, 5, 4, 3, 2, 1 on the top and bottom, which would cancel out. So n choose 1 less than the n is also going to be equal to whatever the n value is. Okay. So those are some special cases that'll come up. Like I said, I could give you the same type of problem, but instead of just giving you the formula, I could say I have 10 students in a class. I want to choose 4 for a committee. How many ways how many different groups can I pick? That's 10 choose 4. So either using your calculator or doing the algebra, you should be able to come up with the correct answer. But that's it for today. If you guys have any questions, please reach out to me. Otherwise, have a good day. I will talk to you soon. Bye.